Okay, we're going to do a test. I've got 4 different GPX 5000 detectors, and I have them all on a cancel coil in the workshop. I'm going to set these up so they're all very much the same, and we're going to do some sensitivity and noise testing. So this one here is Ron's standard 5000. All these are set in normal mode. Deep, wait for that to finish. Deep, normal, mono, fixed or tracking makes no difference. Tracking. That is the residual noise in this room. And I would say there's a washing machine and a dryer on at the moment. I'm just guessing that. But all these are set up the same. 0.1 gram in normal mode. Can I say it's a cat? I haven't got the connector done up, so I just bumped the cable that went off. But that's pretty much the amount of noise I'd get in here off any 5000 detector. So this is totally standard, non-modified GPX 5000. We'll put it down there. Okay. Next one. This is a standard detector. I use this as a standard yardstick. It has no modifications. It is factory standard. So we'll stick this one on. Now, if I did use a double D coil and had it on the detector in cancel mode, it would be a lot quieter than using this coil. Even though it cancels out electric interference, radio waves and so forth, I cannot cancel out magnetic interference from the AC mains. Any heavy currents which is generating a magnetic field, you cannot cancel out. No matter what you do, you can't do it. You'd have to have a big, thick metal room, and it would be have to be made out of steel, probably about that thick, or it would have to be made of thinner material, nickel, or a mu metal type structure. It would still have to be very thick to circumvent the magnetic fields that are all around us. We can't do anything about it in suburbia. So anyway, next GPX 5000, I'll just make sure. Deep, normal, in mono, and it's in tracking. Now I have noticed that the audio is a little bit lower on this one. It's typical of all these 5000s. I've never ever found two that are exactly the same. I'll turn it off, and I'll just actually default to factory just to make sure the audio is set correctly. So I did it on that one. I might have missed this one. Okay, that's factory default set. And yeah, it's a little bit more noisy, but the audio level is less. And after I've done that, the detection depth has come back a little bit. So this one down here, even though it's noisier, this the RON number 2, the standard one, even though this one is noisier, it has greater detection depth than that standard one there. Like I say, these things are all up and down percentage-wise how they operate. There's nothing we can do about it. It's a way it is manufactured to start with. Okay. This one here, I just repaired this one. This was noisy, and it was big component failure noisy. So this is belongs to Gerard, and it is just basically a standard, unmodified, repaired 5000. So we'll have a listen to this. If I get the plug on. I'm not going to do it up because I'm not swinging it. I don't need to. It's stable. So we'll turn it on. We'll have a listen to what it does. Now notice, the audio on this one is loud as well. It's louder than the other one. I haven't changed anything and the audio's louder. Okay. Maybe there's an edition 1 and 2 in the GPX5000. I don't know. Like I say, I didn't manufacture it. I don't know. Okay, deep, normal, mono, tracking. Now listen, this thing here, just being in this room is going to generate noise. I could try and change the frequency of it. We'll have a look. I went past it, didn't I? There it is. Okay. I'll change the frequency and see what happens. I mean, you can pick it. It's probably the best we can get it. If you get it onto a harmonic of 50 hertz, it's going to go completely ballistic, as in nuts. But anyway. Same as RON number 2 standard detector. And this is actually probably more noisy. So this is noisy. Okay, now we got RON number 1 modified 5000. Let's see what happens. Now I put new capacitors in this detector. I put in new front-end transistors. I put a new subboard in it. The rest of it is factory componentry, manufactured by Minelab. I can't change the basic functionality of the detector. You know, if it was a made on Friday detector, it is what it is. If it's a made on Monday detector, it is what it is. It's a midweek detector, it is what it is. So let's try it out. Let's check the settings. Deep. It's in tracking. The gain on this is fairly high, not all the way up, it's about 3/4. It's probably 2 inches past the end of this shaft, which is actually better than the other detectors were doing. But we got a lot of noise, so let's get rid of some of the noise if we can. Okay, this has got variable frequency in this detector as well, and changing, there's that 50 Hertz harmonic. I've got the frequency setting at 163 at the moment, and it's probably not going to get any better. It will not be quiet in this situation. But we've got our 0.1 grammer. It's punchy. Just looking for a hot rock to do a ground balance test. I had a good one here somewhere. Kalgoorlie Special. I think everyone knows what these are. We flick it from back into fixed and flick it back into tracking. Totally ground tracked out. So we got more gain here. We can crank the gain up, but like I say, it's hard to hear the noise, but it is killing the other detectors on depth. Now that's all GPX 5000s, 4 GPX 5000s of various types. Now if I go through here, what have I got? Dear. What's this? Okay, I have in bits a standard 4500. Okay, so what I'll do, I'll just put this one on the bench. I can't even remember if this works or not. This is a standard 4500 that was repaired. So what we'll do, I'll put it all together. Hopefully it works. I don't think I've put my hands on this detector for a fair amount of time. So standard 4500. Get the cable. Okay, we'll turn it on, just make sure it works. Okay, now what I'm going to do, I'm going to put it in factory default settings. Okay, reset all. This is in cancel mode at the moment, I can tell because it's dead quiet. Okay, it's in mono, tracking, normal, deep. Now, if you listen to the profile of a 4500, it's still picking up the noise, but it is softer. This is the difference between 4500s and 5000s. It's on normal mode, they're all on normal mode. There is no difference. So we've got normal, tracking, mono, deep. 0.1. It detects out as probably not as far as the modified modified 5000, but it's quieter. So it's quieter, but it's still got that noise. If this had external gain on it, and I cranked that gain up, it would be making more and more noise as I did so. There is a complete difference between the 5000 and the 4500 in the way it handles impulse noises and so forth. And it just gives a clearer signal. But it's a 4500. How about I see if I've got a modified 4500. Now you got to remember that a 4500 is not a 5000 and a 5000 is not a 4500. They are completely different beasts. The 5000 is more or less made for tiny, tiny gold. The 4500 is made for larger gold. Well, at least I know that works. That's good. So I'll put it back in its thing here. There we go. You can go over there. Okay. Now, this is 4500. This is my own thing I do all my testing with. It's highly modified. This is the one I call no ears. It has the same modifications that is in the 5000. The modified 5000. So even though it looks a bit ridiculous with no legs on it, that's how I got it. Someone chopped them off. Okay, I'll just turn this on. I'll turn the gain right down so I don't blow my ears out. But we'll set it all up and we'll treat it like a, like I say about blowing the ears out. Okay. I'll reset it back to factory default. Notice too, the audio on this is louder than some of the other detectors. Okay. Normal, mono, tracking, deep. And I'll turn the gain up. Well, we'll just have a look. I have to get really close to the coil to get that. Probably halfway. The modified 5000 has more detection depth, but it's noisier. This is less noisy, but I'm only at half gain. I'm about 3/4 gain. And of course the noise is going to come up. It's on par with the 5000, but as the gain goes up, the noise is going to go up too. So I'll see what I can push this out to. Now, on a cancel call, you're going to get a phase imbalance. It upsets the detector and at full gain, it'll swamp the front end, and the detector goes like that. If you ever hear your detector do that, you've got too much capacitance in your coil, right? And because it crosses over, it adds capacitance, and the detector's shut down more or less. So you're just going to back it off till it screams. So that's 9/10 on the gain, and the detector's back in action. So you don't crank it up on some high capacitance coil, it'll kill the detector. So if I was using a double D as a cancel coil, I could run it full gain easy. It's not a problem. Okay, like I say, it's set up the same way as a 5000 is. It's noisy, and we're at about 9/10 of gain. So I'll disconnect this one. And if I get the right one here, okay, this is the modified 5000. I'll quickly put it on. We'll see how we go. Now see, I've turned that full on the gain, and it's totally desensitized, same as the 4500. Only does it on this coil, or these type of coils, or a badly made coil. Okay, we've taken this one down to about maybe 8.5 out of 10, and I can hear harmonics of 50 hertz coming straight through, so we have to adjust the frequency. Now, I've adjusted the frequency 2 clicks, and that repetitious noise is 50 hertz. That's more random. So that's just noise everywhere. So we'll get our 0.1. There's more noise there, but it's the way these detectors work. It's the same as every other 5000. It's probably on par with that modified 4500. I'll just put this on enhanced just for fun. And there's too much noise for enhanced to actually pick that up on this one. I mean, the amount of noise pickup is overwhelming the signal. So I'll turn the gain down. Turning the gain down's improved the amount of depth, but the signal intensity is less. It's because we're getting the noise out the system, but we're also turning the gain down, which is definitely going to have a depth impact. So in a lot of cases, if you do have noise, local noise, you want to try and get the noise out and have as much gain, but make the noise bearable. Put it back in normal. Now, with the variable frequency, I'll just turn that amplifier off while I do this. Okay, let's take this up to around about 200. I'll put the gain back up. Hang on. Okay, about there. 8 out of 10 seems to work. And I'm back on a 50 hertz harmonic. You can hear that whoa, whoa, whoa. Power lines, always power lines. Okay, I've gone 202. You hear it's still on the edge of it. It's just getting that whoa, whoa sound. Anyway, let's have a look at higher frequencies. There's too much noise in here overall, and it's just swamping out everything. Okay, I'll just put this detector back into factory default. Okay, it's factory default. And straight on some harmonics of now, if you say, is the noise generated by the detector or external to the detector, it's really easy to prove it. Turn the gain down. Does the noise go away? 90% of it, it's external noise. If you turn it, if you're out in the field and you turn it all the way down and you're still getting a bit of noise, maybe there's something in the detector. But normally the detector, if you turn the gain right down, it's not going to shut right up in a house with electrical equipment, lights on, and I'm pretty sure, like I said before, the washing machine is going and the dryer's going, because I know someone's doing that out there. So we can then say, now, with the gain all the way down, maybe you can tune out the noise more easy, because there's just so much noise at high gain, you can't do much about it. So I'd say we're pretty close to getting rid of the noise. Now, if I lift up this cancel coil and get it away from the ground, try and get it away from all sources of power. Actually, what I should do, I'll try and hold it like this. Just me tilting it, it's actually interacting with things in the room. That's fairly quiet for in the room. What we'll do, we'll prove a point. I'll connect up a double D coil to it. Put this in cancel mode, because if there's anything in the detector whatsoever that's out of balance, not functioning correctly, no matter what it is, it won't work properly in cancel. Now this is the way you test it. Okay. I have a standard Minelab double D. And I just realised how heavy they are. Anyway, we'll put this on. And because I'm going to be wiggling it around, I'm going to do up the coil connector. Put this on cancel. And let's have some let's experiment. Right, so we got this here. I'm not properly set up to do this. Now, let's turn this detector right up. That's as good as any detector gets. That is extremely quiet. I'm amplifying the absolute bejesus out of it, out the audio. We're only on 0 gain, by the way, so I'll turn the audio down so I don't blow our ears out, and I'll start cranking up the gain. Okay, everything's exactly the same except we are in cancel mode. Now here's the thing you notice. Now I'm on full gain and the detector didn't shut down because these coils are better and less capacitance than the cancel coil. So it's in normal mode. We've got rid of all the AC electrical interference. The non-magnetic components of the AC is cancelled out by one of these coils. The magnetic components are not. There's still magnetic parts of the AC waveforms traveling around, and you can hear it drifting in now. That's typical AC 50 hertz interference coming in. Like that, woo, 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 like that. And if you offset it with the frequency control, you can get the change in rate. If there's something else out there and you can beat the two frequencies together, it'll make a different rate. But at the moment, we are absolutely turned on full gain, all right? Cancel, normal. So let's put it in enhanced mode. It's in enhanced mode. Now in enhanced mode, I can put the frequency up and it's going to detect out a lot further for smaller gold. Low frequencies for big gold, high frequencies for small gold. And because I've gone to enhance, I can hear a little bit of electrical interference coming through. These detectors aren't 100% stable in their frequency. The frequency for the transmit receive is generated by a LC oscillator. It's not crystal controlled, right? And slight temperature changes change the inductance of the coil and the capacitor in the LC timing circuit, and they drift. So if you put a detector out in the sun from somewhere where it's been shaded, and there's an interference source around, the detector will eventually cross a harmonic of that interference in most cases, and you'll say, well, why is the detector going crazy? It's only because the detector's warmed up. And if you readjust the frequency once it's warmed up, with the temperature being constant, you should have no more problems in that regard. So what we'll do at the moment, we'll get this. I'm bending the cable, which they don't like. Okay. Okay. There we go. I've got the frequency up around 200. And it depends if I've landed on any noise sources. Even using the cancel coil, you can't get rid of the magnetic component. Just remember that. It's gonna be there. It's gonna be traveling through my body, even up the floor, everywhere. So point one. Now you got to remember, I've got this in what? It's in enhanced at the moment. 0.05 micro type gold. Even in a noisy environment, in cancel, you lose a lot of your signal in cancel, by the way. Okay. Put it back in the normal. A normal 5000, with that in normal, you have to scrape the coil like that to hear it. This is way off the coil. You know, I'll hold it up like this. I don't know if you can see it on the camera. Yeah, round the right way. And I'm squashing everything up here. And that's a 0.05. If I do on a 0.1, it's going to be a lot louder, of course. We'll try ground balancing on the Kalgoorlie Hot Rock. Okay, I'll go from tracking, put it back into fixed to activate the fast 10-second fast tracking when you go back into tracking from fixed. There's no problem tracking it out. Now, the only thing I've got, I'm getting more interference coming in. I can tell that a mile away. We're up at about 220 in frequency now. But you got to remember, our gain is on full gain. You can't do that with a standard detector. I'll prove it. I'll get a standard 5000. What do you mean? Okay, normal mode in cancel, and I'll put it on full gain. You get an idea how deaf it is. Standard 5000, been used as a test target, standardized test target, test detector for years. Okay, we'll do it all up. We'll do it properly. Okay, tracking, mono. Try putting it in cancel, deep, normal. Okay, I'll even do up the back connector. Make it all over the top. Now, standard detector. Now, you've got to remember, there's no boost gain on this detector. So it's going to be quiet. So let's go in the back menu. Okay. Now the warbles still come through, even though it's got no boost, and I've cranked up the back gain on this detector. We're in normal. Let's see how we go if we can pick up the 0.05. Righto, 0.05. It doesn't even know it's there. Just starting to realise now. I've got to scrub the coil to hear it. I don't even know if you can hear it. Have a listen. I'm scrubbing the coil. I'm going around circles. I can, if I stay in a very small, tight grouping, I can detect it. Now I'll move it about 10 millimeters away from the coil. Now I'll move it about an inch away. Very weak, and the only reason you can probably hear it is because there's so little amplification that we're not bringing in a lot of noise over the top of it. So if you compare a modified 5000 to one that is standard, there's going to be a definite difference in detectability. So you could hear the signal response. That signal response on a small gold will even become a greater signal as gold gets bigger. Okay, that's the standard. I want to get the other one. I've got 4 detectors here, so I've got to grab the right one. So we go back to the modified one. Now, what I can do, let's do this as an experiment. I'll turn this on. Bear with me. We're going to do a lot of experiments here to prove points. Okay. How about we'll turn that right down. I've turned the RX gain up to 20 on this. Right? Scrub the coil again. I've got the gain at the front end turned down to 0. It's got no front end gain. Okay? Now, it's still picking up warbles from interference, even with a cancel coil. The other one did the same. So you can hear the warbles. So I've got the back gain on this thing cranked straight up. The back gain will amplify any discrepancies inside the detector. It's going to amplify it a lot more than what the front end does, because the front end overcomes the inconsistencies inside the detector. So let's crank it up. We'll make sure that we're in the right settings. Normal mode. Let's take the gain up a little bit. It's about 2 out of 10. Scrubbing the coil. That's a good 1.5 inches away. I'm still getting a good clear signal. Just shows you the front end, even though the gain's low, it's got a lower noise figure than the standard way the detector works in the front end. That's about 4 out of 10. Now that's killing a standard detector for depth. It's leaving it in the mud. I'll hold it like this so you can actually see. Okay, so about 6 out of 10. We are going to start dragging noise in no matter what, because even the double D, the windings for the transmit are thicker than the windings for receive that are thinner, and they're both different inductances. So what happens is the coil is going to cause an imbalance, and it's because it's intercepting interference in both coils and we're in cancel mode, it will send the imbalanced signal to be cancelled. But because it's imbalanced, you can't, cancel out with a 180-degree phase shift on it and expect it to cancel, because first of all, you haven't got that 180-degree phase shift by having the two equal signals. They're different because of the windings. But anyway, we're up. We got a bit of noise. I'll just hold this in the right angle. Now this is what I'm saying about signal to noise ratio. Rather than saying, oh, let's go crank the gain flat out, right? I'm picking up the detectors under me, under my feet. But anyway, when you start bringing up the noise is competing with hearing the signal, right? And you have too much noise. It's like a whisper in a room of crowded people. You've got to shut the people up to hear the whisper. And that's basically what's happening here. We got the gain cranked up. The back gain's on 20. There's a lot of noise coming in that you can't even hear. It's being going into the electronics and getting squashed out by the electronics. But it lowers what we call the dynamic range of the detector. Even though I can hear that, the noise is overpowering all the circuitry in the detector. If I rub the coil, so you're actually better off putting the gain back. We'll go right up though, just to prove a point. Okay, that's about 9 out of 10. It's noisy as hell. It's actually killing our depth because of the noise, the electrical interference. You can hear it. But even so, we're killing a standard detector. And we brought all that noise up, which we don't want. Now remember, on a standard detector, you could scrub the coil and you'd hardly get much of a sound. But the noise is killing it. The noise is mixing with the signal. So I'll turn it down all the way to a gain of about 2. Because I got rid of the noise, I can hear the signal far more clearly. That's how these things work. But you want to run as much front end gain as possible and not back end gain. Like this thing's cranked up at the moment, flat out. So if I put the back end gain back down to whatever it was, 12 I think is factory. It's on 12, right? Really, really quiet. Even though I've got the front gain only on about 2 out of 10, right? Got rid of all the noise and you can hear the target clearer. Thus you can say, just listen to the ambient noise, turn the front end gain up. Let's say where? It's about 4. That's about 5. Now, we haven't brought up much noise. The back gain on these detectors brings up a lot of noise. The noise has come up fractionally, but the signal response is massive compared to where it was. So the modified 5000 is working fine. There's nothing wrong with it. It beats the other detectors. It's pretty well close on par with the 4500, but the 4500 is made to do bigger gold, whereas the 5000 is made to do smaller gold. So in all that, if I can test that in this room and get consistent target responses better than standard detectors, it basically means this one is working fine. The other one is working on par with the other standard 5000s. It's not noisy, it's the same. So I don't know what all this noise is generated from. It must be local to where the detection is occurring. It's really got me bamboozled. It's like banging your head against a brick wall and expecting a change to happen, and it never changes. So, in my qualified opinion, those detectors are working perfectly, and the modified 5000 exceeds the performance of the other detectors, the other standard ones. I can't prove it any more than that. It is what it is. Out in the field, obviously, everything's going to be a heap quieter and the noise is going to go away, right? But if there's a noise source out there, you can't escape that. Whatever that may be, I don't know. I'm only speculating what it could be. Um, it doesn't produce its own noise. It just does not do that. So the best I can explain it. Anyway, what did we go through? We went through 4 5000s, the standard 4500. I could do the modified 4500, but it's sitting over there ready to go out for a test. We're in a bit of a swing. So I hope that explains everything, because otherwise, you know, I just don't know. Anyway, that's enough.